Hey y'all, back again. This time with chapter number 8. And I'll go ahead and say it straight up. In my opinion and Mr. Spillman's opinion, the name of this chapter is the most dead marker of all time. Now, the most important chapter. And I mean it here. This is perhaps the most important chapter in all of the class, and in my opinion and Mr. Spillman's opinion, it really is. And you're probably thinking, well, wait a minute, why? Well, that's because we deal with trigonometry. You see that word over and over and over and over and over. And so trigonometry comes back into play in Algebra 2, in pre-cal, and in calculus. You then see vectors. Well, guess what? Vectors show up. Let me scoot this down a little bit. Vectors show up in Algebra 2 and in Calculus 3. So for my people who want to make a lot of money, vectors are going to show back up. And then tree diagrams, for those of you who want to go into being an actuary or a statistician, another field where you can make a lot of money, tree diagrams you're going to see in stats or data measurement if you take that class. So you can see here, stats, data measurement, Algebra 2, Calculus 3, Algebra 2, Pre-Cal, Calculus. This is a very important chapter, and I just wanted to reinforce that. And let's start actually with the bottom here. Let's start with the last thing, tree diagrams. So as you go up to day 1, hopefully you have seen tree diagrams before. Tree diagrams always involve probability. And so a tree diagram always involves probability. And we want to be able to use a tree diagram to check this out, that models a process. And we use a few rules that you're going to learn about a little bit later, the complement rule, multiplication rules, and conditional probability, which we have seen before, the whole given that principle. When it comes to conditional probabilities, given that this, what would the probability be of that? And so a tree diagram shows the sample space. When we talk about sample space, we use the letter S. We use the letter S when we talk about sample space of a chance process involving multiple stages. That's where the tree comes in, multiple stages. So the probability of each outcome is shown on the corresponding branch of the tree. So the probabilities are shown on the next branch. So comes after. All probabilities after the first stage are conditional. After the first stage, everything is based on what came before it. So after the first stage, everything is based on what came before it. Okay. So let's really start by digging in. And what I love to do is, as I read, I make the tree. So check this out. As we read, we're going to be making the tree down here too. So a computer company makes desktop, laptop, and tablet computers at factories in 2 states, California and Texas. So immediately I know that I'm going to have California on one branch and Texas on another. The California branch produces 40% of the company's computers. So 0.4, 40% of the company's computers, and the Texas factory makes the rest. Remember, probabilities, I'll give you a quick reminder, probability adds up to 1, which of course we know represents 100%. Probability adds up to 1. So 0.4, that must mean Texas is going to be the other 60%. Now, of the computers made in Texas, so we're down here, check this out. 10% are desktops, 20% are laptops, and the rest are tablets. So I say, okay, I'm going to have 10% are desktops. So you could do 0.10 or just 0.1 would be good. Another 20% are laptops. Put lap, and that would be 0.2 or 0.20. And then finally, the rest are tablets. So that'd be 30%. That must mean this is going to be 0.7 are tablets. So this all adds up to be 1. This adds up to be 1. Now check it out. Let's go back up here. Sorry, I skipped this, my bad. Of the computers made in California, 25% are desktops. Okay. So desktops, we got 0.25. 30% are laptops. And the rest are tablets. So that would be 55%. That must mean that this last bit is going to be 45% for tablets. And of course, that plus that plus that adds up to be 1. So now, we've got our tree here. Let's talk about the conditional probabilities. So this is after the first stage, everything is based on what came before it. So when we talk conditional probability, we look and we say, okay, now is where we bring in what I like to call the and situation, where we take this and take this to get each section. So you've got this lining up to that, this lining up to that, this lining up to that, and then down here you've got this lining up with that, this lining up with that, and this lining up with that. 3 blanks for these 3 coming through like that, and then 3 blanks for these 3. And so when we use the word and, remember guys, we're multiplying. When we use the word and, we are multiplying. So let's take these probabilities and let's find out what they're going to be. What's the probability that a computer comes from Cali and is a desktop? Well, that would be 0.4 times desktop would be 0.25. Gives you 0.1. One more time, and then I'm going to let you guys get the rest. Cali, 0.4 times laptop, 0.3, 0.12. And so I want you guys to pause the video, see if you can get the rest for me. Go ahead and try the rest. You can go ahead and pause. All right. And of course, you guys probably already know, all of these are going to add up to be 1. All these add up to be 1 here. So adds up to 1, adds up to 1, adds up to 1. All phases. Okay. Now let's start answering some questions. So suppose we select a computer at random. And so here's the thing. Find the probability that that computer was made in Texas. Well, Texas, there's a 60% chance. You could say 0.6 or 60% chance. How about find the probability that the computer is a tablet? Ooh, here's where we got to be careful. We got 2 sets of tablets here. We got these tablets and we got these tablets. So it looks like the chances of a tablet being made out of Texas are 0.42. The chances of a tablet being made out of Cali are 0.18. So we would say, okay, Cali's going to be 0.18 plus Texas is going to be 0.42. And so what would be the total chance that no matter where we went to, no matter where our computer came from, that we would get a tablet? Well, add them up. They give you 0.6, or about 60% chance that the random computer you got from either one of these centers, or that the random computer you got was a tablet. Sorry, got a little tongue-tied there. How about this? Find the probability that a computer was made in California and was a tablet. Well, heck, we just did that. The fact that it was California, was a tablet, we know that that would be 0.18, or 18%. And then last one, ooh, this is going to be tricky. Given that a tablet computer is selected. So in other words, given that we are dealing with only tablet computers, which we know makes up 60%, or 0.6. So given that we've got a tablet, let me bring this down here. That would mean our denominator is going to be 0.6, because we know 60% of our computers are going to be tablets. What is the probability that it was made in Texas? So then we say, okay, looking at Texas, looking at tablets, boom, 0.42. So this is the Texas, this is the tablets. All right. And I'll let you guys do the math here. Let's see what we end up getting. What's 0.42 divided by 0.6? So given that we're looking at tablets, what's the chances that it comes from Texas? Boom. You got a 0.7 or 70% chance of any tablet being made in Texas. Hey, would you look at that? 70%, 0.7. And so guys, I'm going to pause. This will be the end of video 1. Ooh, spooky. So this will be the end of video 1. I'll see you guys over at video 2. See you in a little bit.